Welcome, dear students. So in this video lecture we are going to study quantum numbers. Okay, in last video lecture we studied about Schrodinger's equation and wave function. Okay, I will show you one or two graphs that I will show you later, given in NCERT book. But today we are going to discuss about various quantum numbers. Okay, so in last class we have seen this symbol psi. I called it wave function, and I told you that psi square gives the probability of finding an electron. Okay, now we will define some parameters. These are called quantum numbers. And what these quantum numbers do? So we have seen that psi square gives us the probability. Okay, that means probability of finding electron in any specific region of an atom. Okay, so we will see that suppose if we have a region around the nucleus, it could be spherical or it could be cubical. Well, there is no cubical, but it may be cubical. So we will see that the region in which we are finding the probability of the electron, what is size of that region, okay, what will be the energy of electron in that region, what is shape, orientation and other things. And to explain these things we need some quantum numbers. Okay, now what does this quantum number tells us? What are these? So first is principal quantum number. And the symbol is n. You have already got this n. In Bohr we have used n equal to 1, n equal to 2. So this is what principal quantum number is, basically the orbital. Okay, so what does principal quantum number tells us? It tells us about the size and energy of the orbital. Okay, it gives us information regarding the size and energy of the orbital, how big the orbital is, and secondly that what is the energy of that orbital. We already know that as we move away from the nucleus, the energy of electron in an orbital, basically energy associated with that orbital, increases. Okay, so and obviously as we move away the size of the orbital also increases. Okay, so this is what n is. N can be, the value of n can be 1, 2, 3 and so on. Next, this quantum number is new. We have Azimuthal quantum number. Azimuthal quantum number. Sometimes it's called secondary quantum number. N denoted by L. So what Azimuthal quantum number tells us? It also tells us about energy and number of subcells. Number of subcells. So what is energy we know. Okay, so Azimuthal quantum number will also tell us about energy. But now we have seen something which is called subcells. Now what is subcells? Okay, so we will learn about subcells, but let's get into some rules regarding L. For any particular value of n, possible values of L is n minus 1. Okay, this is a rule. So what it tells us that suppose the value of n is 3, then L can be 0, 1 and 2, and it cannot be 3. Okay, if n is 3, then allowed value of L is 0, 1 and 2. Okay, the allowed value of L is 0, 1 and 2. Okay, for any value of L, number of subshell is 12 plus 1. That means suppose if we have L 0, then we will get that 2L plus 1 value will be 1. So we have one orbital. If the value of L is 1, we will get 3. So we have 3 subshells. If the value of L is 2, we will get 5 subshells. 3, 7, okay, 4, 9 and so on. So this is the number of subshell. Okay, now I will tell you what subshell is. See, in your home, sometimes you have a box. Okay, if you have a box, you can put your books, your clothes or any useful item in this box. Now we also have almirah at our home, and the almirah has different closets. So you can place book here, clothes and so on. That means it's one box, you can close it. If you close the almirah, it is a one box, but when you open it, it has different individual closets or boxes. Okay, that means that the complete box consists of small boxes. Okay, so orbital is something like subshell is something like that. In Bohr, we have seen that there are orbits like n equal to 1, in n equal to 2. Now we will see that in n equal to 2, we will have some subshells, suborbitals. Okay, so this is what L, the azimuthal quantum number, tells us. Okay, and what is the number of subshell? The number of subshell is 2L plus 1. Okay, now you have to know these names. If L equal to 0, we will have s orbital. The name is s orbital. If the value of L is 0, then it's called s orbital. If the value of L is 1, it's called p orbital. If the value of L is 2, it's called d orbital. And if L is 3, it's called f orbital. Okay, f orbital. So s, p, d, f. Okay, depending on the value of L, we have different names. So L0 s orbital, L1 p orbital, L equal to 2 d orbital, and L equal to 3 is f orbital. You have to keep in mind that you have to remember these things. Okay, because we will be using the value of n and L all the time. You have to recognize the orbital. If the value of L is given, you have to recognize whether it's a s orbital or whether it's p orbital. Okay, and how you can determine? If you know the values, that if the value of L comes out to be 0, then you must know that it's p orbital straight away. Okay, we will see about subshells in detail also, but before going to that, I will define third quantum number, and that is called magnetic quantum number. What is magnetic quantum number? It tells us about the spatial orientation. The spatial orientation. Oh, one more thing I forgot about the in L, azimuthal quantum numbers also tells us shape of the orbital. Okay, shape, whether the orbital is spherical, cylindrical, or what kind of orbital we will have, the geometrical shape it tells us. Okay, I will go into that in detail. So magnetic quantum number tells us spatial orientation. What kind of spatial orientation we will see, but first of all, just like p orbital, we will see there are certain specification. Value of ml depends on value of L. And how it depends on L? So see, suppose L is equal to 0, then ml can have only one value, that is 0. If L is equal to 1, the value of ml is -1, 0, plus 1. If L is 2, ml can be -2, -1, 0, plus 1 and plus 2. Okay, plus 1 and plus 2. Okay, see, for ml you have got 3 values. Okay, -1, 0 and plus 1 is 3 na? This is 1, this is 3, and you will see that this is 5. Okay, so and what we have seen, আমি কি চাইছিলো L এর ভ্যালু সাউথ আমি কি চাইছিলো যে নাম্বার অফ সাবসেলস কেইটা থাকে 2L + 1 আমি 0 কারণে এটা পাইছিলো যে এটা সাবসেল হ'ব সো ml এর এটাই ভ্যালু আইছে আমি L = 1 এর কারণে চাইছিলো যে আমার সাবসেল কেইটা হ'ব 3টা ঠিক আছে সো ml এর 3টা ভ্যালু পাইছো সিমিলারলি L এর কারণে আমি পাইছিলো L এর 2 হলে আমি চাইছিলো যে 2L + 1 ভ্যালুটো কিমান হ'ব পাৰে 5টা হ'ব পাৰে আৰু সো ml আমি কিমান পাইছো 5টা পাইছো -2 -1 0 +1 +2 that means 1 2 3 4 and 5 we have got 5 values for ml. That means these 5 values of ml tells us that there are 5 subshells. Okay, there are 5 subshells. So let's now let's go into the detail of the spatial orientation and shapes. So actually s orbital that is when L is 0, so ml is 0. Since L is 0, so ml is 0, that means we have only one value, that is one subshell. So s orbitals are actually spherical, they are spherical. Okay, and you may also say that since we have got only one subshell is there, okay, you can say, if you just compare with the almirah that we discussed, so you can say that each box, okay, each box or each subshell is just like a box. Okay, just like you can arrange your books, cloths in your box, in these subcells, treat these subcells as box, and you can place your electron in an atom in these boxes. Okay, আমি electron place কৰিব পাৰিম এইবিলাক বক্সত ঠিক আছে আমি বক্স হিচাপত কনসিডাৰ কৰিম তেতিয়া হলে আমি কি গম পালো s অরবিটালত কেইটা বক্স আছে এটা বক্সে আছে ঠিক আছে এটা সাবশেল আছে তার মানে এটাই বক্স থাকিব s অরবিটাল যেতিয়া থাকিব আমাৰ বহুত কিটা s অরবিটাল আহিব পাৰে কিন্তু আমাৰ যেতিয়াই s অরবিটাল থাকিব তেতিয়াই আমাৰ সাবশেল কেইটা হ'ব এটাই হ'ব ঠিক আছে তার মানে বক্স এটাই হ'ব যদি আমাৰ l ভ্যালুটো 1 হয় তেতিয়া আমাৰ অরবিটালটো p হয় আৰু তেতিয়া আমাৰ ml এর ভ্যালুটো কি হৈ যায় -1 0 + 1 আৰু আমি সাম p orbitals are dumbbell shaped. Dumbbell shapes. Dumbbell means that আমি যে জিমত যেটো ইউজ কৰো কেনেকুৱা হয় দেখাত এনেকুৱা something like this. So suppose this is y axis, this is x axis, and this is z axis. So this dumbbell is in y direction, oriented in y direction, so this is called py. if the dumbbell is oriented along, x direction, then this is called px. Okay, and suppose the dumbbell is oriented along z direction, that is called pz. So px, py and pz, combination of these three subshells ultimately gives us this p orbital, which is dumbbell shape. That means in p orbital we will have three subshells together, or these are called three subshells, that means three boxes. Okay, and when an orbital has these subshells or something like that, that means I just write it like this: px, py and pz. We will see that these three p orbitals, since they are part of the same orbital, the boxes are within the same almirah. When we open the box, we see that there are three boxes. Okay, so something like that. That is, p orbital has three boxes. Okay, so when we have multiple subshells, just like in case of p, we have three subshells. We will see that these three subshells, that means all the p orbitals, whether it is px, py or pz, they'll all have same energy. Okay, they will all have same energy. That means there is an energy difference between s and p orbital, because s orbital and p orbitals are different. But px, py, pz are part of same p orbital. Since they are part of the same p orbital, so they have same energy. Px, py, pz, they have same energy. Okay, and that's why sometimes they are called degenerated orbitals. Okay, so these are called degenerated orbitals, where we have multiple subshells. Okay, let's now try out d orbital. Let's try d orbital. Okay, so in d orbital, the value of L is 2. So the value of ml will be what? -2, -1, 0, +1 and +2. That means we have 5 values, and it corresponds to dxy, dyz, dzx, dx square minus y square and dz square. I will tell you what these are. See, in P we got only px, py, pz. It says that p orbitals they are dumbbell shaped, but they are oriented towards the axis, on the axis. Okay, but d orbitals, there is xy or yz, something like that. It's not like x, y and z. So what is xy? So when we mix two axes, that means x and y, the region between x axis and y axis is called what? A plane, xy plane. So it suggests that the d orbitals, the 5 d orbitals, the 5 subshells that we are getting, we'll get 5 subshells, 5 boxes in d orbital, and all these d orbitals, all these d subshells are, first thing, they are planar. That means they are in a plane. And second thing, d orbitals are double dumbbell shaped. So what is double dumbbell? I will tell you. Okay, so this is dxy. The lobes that you will see is in xy plane. Okay, in the xy plane, and there is two dumbbells. There are two dumbbells. Okay, So this is, you know, d orbital, and it's called, it has a shape of double dumbbell and planar. Okay, and there are 5 subcells. So in this way you can determine, you know, how many subcells are there, that means how many boxes are there. Okay, and then we will see how we place electrons in different orbitals. Now see, last quantum number that we will study in this video lecture is a spin quantum number. Spin quantum number. Okay, so what is a spin quantum number? Spin quantum number gives us information about the spin of the electron. That means in nucleus the electron may go clockwise or anti-clockwise in an orbital. So in which direction it is moving, this information is given by spin quantum number. The value of ms can only be plus half or minus half. That means spin up and spin down, clockwise, counterclockwise. You can say clockwise, counterclockwise. That means if we have spin up value, that means the rotation of the electron is, you know, clockwise, and if we get spin down value, that means the electron is going in a counterclockwise direction. Okay, so plus half and minus half. This is all about, you know, only these 2 values are sufficient to specify the rotation of the electron. Okay, so we have learned about different quantum numbers and what do they tell us, how what are the information, some few basic rules associated with these orbitals. And one more thing you must know, the boxes that I was talking about, a single box, that means subshell. You say, so maximum 2 electrons can be placed in a subshell. That means in any subshell, whether it is P, S or anything, like see in P we have 3 subshells. Now I'm not talking about the orbital, I'm talking about subshell, mind it. So it has 3 boxes. S has only 1 box. If it is S, if it is P, P has 3 boxes, S has only 1 box. So each box will contain 2 electrons, can take up to 2 electrons. That means this box can take 2 electrons, this can take 2, this can take 2, this can take 2, maximum 2. It may have 1 electron, but maximum how much it can take? Maximum electron that it can take is 2, not more than 2. So each box, each subshell will get maximum of 2 electrons. Okay, so this is all for this video lecture. Okay, so we have introduced our quantum number. We will in next video lecture we will see some basic principles and we will see how to construct orbitals and then how electrons are filled in these orbitals. Okay, so we will get some rules. Thank you.